Welcome to the Explainer. Today, we're going to break down a huge topic in programming and make it super clear and simple. All right, let's kick things off with a problem every single programmer runs into. You know the feeling, right? You're writing the same variables, the same logic in a bunch of different places. It's not just boring, it's a recipe for disaster. Because if you find a bug, you have to remember to go hunt it down and fix it in every single spot. What a nightmare. So, imagine you're coding up a program for vehicles. You make a car class, you give it some speed, a color, you make it start and stop. Great. But then you need a truck class. Well, a truck also has speed and color, and it also starts and stops. So what do? You just copy and paste the code? Ugh, that's messy, and it's going to be a real pain to manage later on. There's just got to be a better way to handle this, right? A smarter way? And guess what? There is. This exact problem is why a core concept in object-oriented programming was invented in the first place. So, let's dive in. The solution is this really powerful idea called inheritance. Basically, it lets you set up relationships where one class can automatically get all the features of another class. You can literally think of it like building a family tree for your code. And it's pretty straightforward, really. You've got two main players. First, there's the parent class. We call it the superclass. This is where you put all the common stuff. Then you've got the child class, or subclass. And the child, well, it automatically gets all that good stuff from its parent, completely for free. You don't have to write it again. And why is this so amazing? In a word, reusability. You write your code one time, in one place, the parent, and all the children get to use it. This right here is the secret to writing clean, professional code that's easy to update and doesn't constantly break. Okay, theory is one thing, but let's actually see how this works. We're going to build out one of these digital family trees right now. So at the very top of our tree, we'll make a general parent class called MotorVehicle. This is where we'll put everything that all motor vehicles have in common. You know, things like an engine that can start and stop or a variable for the fuel level. Now for the next level down, we create a car class. But here's the magic. We don't rewrite any of that engine code. We just say, hey, car is a child of motor vehicle. And bam, just like that, every car we make automatically knows how to start its engine. It inherited it all. And we can keep this going. Let's get even more specific. A race car. Well, a race car is just a special kind of car, right? So we make it a child of car. Now it gets everything from motor vehicle and everything from car. And on top of all that, we can add brand new things that are unique only to a race car, like maybe a method to deploy a spoiler. So how do you actually do this in the code? It all comes down to one little keyword, extends. That's it. When you write public class race car extends car, you're literally telling the computer a race car is a type of car and it gets all its abilities. You know, what we're really doing here comes down to two big ideas, generalization and specialization. The superclass, like vehicle, is the general concept. It's the big, broad idea. But a subclass, like bicycle, that's a specialization. It's a very specific kind of vehicle with its own unique behaviors. And this whole thing has to make sense in the real world, too. You can always say a bicycle is a vehicle. That's true. But you can't flip it. You can't say a vehicle is a bicycle, because that's just not true. Your truck doesn't have pedals. This is a test is a fantastic way to make sure your code structure is logical. So when you add it all up, the power you get from this is absolutely huge. You write way, way less code. Your whole program gets organized into a nice, clean structure. It's super easy to add new features later on. And you can even modify the inherited behaviors to fit your specific needs. And that last point is really, really cool. Think about it. A regular car and a race car can both accelerate, sure, but you better believe they do it differently. A race car can take that accelerate method it got from its parent and completely rewrite it to be way more aggressive. It's called overriding, and it is a total game changer. Okay, so this is fantastic for the code we write ourselves, but how fundamental is this whole idea? Just how deep does this family tree go in a language like Java? Well, the answer might actually surprise you. Let's take something you see every day, a button in an application. You know, you click it. In Java, this is often a JButton. Seems pretty simple, right? Well, that humble little button has a surprisingly long and impressive family history. If we trace it backwards, a JButton inherits from JComponent. JComponent inherits from container. Container inherits from component. We keep going back and back. So what's at the very, very top, the beginning of everything? There it is, object. At the absolute top of the entire Java hierarchy, there is one single ultimate ancestor that rules them all, the object class. And this is a really profound idea. Think about it. Every single class you will ever use or write in Java, whether it's a string, a race car, or a JButton, every one of them is ultimately a descendant of object. It's like the great-great-grandparent of everything in the entire system. Okay, so let's recap the key takeaways. Inheritance is all about creating parent-child classes so you can reuse code. It models the world using generalization and specialization. In Java, that little extends keyword is what makes the magic happen. And finally, every class in Java is part of one single gigantic family tree with object at the very top. Which leaves us with a pretty fascinating question to think about. If completely different things, like a piece of text and a clickable button, all share a common ancestor, what kind of powerful things does that shared history let us do? Well, that's the key to another huge concept in programming, but that's a story for another explainer. Thanks for joining us.